Say, hello, welcome to week 12 of 17, and I don't know if I'm the only one who counts, but anyway, um, we are getting down to the small end of the semester with 2 projects left, so that's all good news. I have a lot to do today, so just a heads up if you're watching the video later or if you're watching the live stream now. Um, Good morning, Isnam. Nice to see you. Good morning, Tony. I'm glad you're here. So anyway, just a heads up. I'm going to put a break in before I do some Project 3 work, but I am going to do some Project 3 work. In fact, I should just add that to the agenda. So there'll be a break after I get through the new content, and then I will start setting up for and discussing what's required for the 3rd project, which comes up sooner than later, like pretty soon, in fact. Let's see. So we are in the week of November 7. Fortunately, the singly linked list will be adaptable. We'll have to make some additions to it, but basically we can build on top of the singly linked list in a way, at least conceptually, to create the data structure that's required for the 3rd project. So we have been doing work toward the ends of the 3rd project, which will include this week's lab, where we turn our singly linked list into a template. If your singly linked list isn't working still, which applies to a few of you, I think, well, this is week number 3 to get that ironed out. Please use Piazza. Some of you do. Many of you probably who are struggling don't. So your classmates are asking and answering questions on Piazza about how to fix their problems with the same labs that you're working on. So I'm pretty sure that if you are still struggling with the singly linked list, it's because you are not taking advantage of those things that are there to support you. Messaging me in Canvas inbox, asking and answering questions in Piazza, coming to office hour, which might mean setting aside time from your week to do so. Your choice, but if you want to get over those struggles, those are the best ways to do that. So good morning, Cass. Nice to see you. Happy Monday. So anyway, this is usually not for the people who kind of reliably watch the lecture video, so I apologize as always for that. But if you know people who aren't reaching out for help in the various ways that you can do that, please encourage them to reach out where you can help them. I can help them. They can get themselves hopefully caught up before they get too far behind that they could hope to catch up. Okay, so anyway, heads up. Today's going to be, I don't know how long. I mean, not 3 hours, not 2.5 hours, but we'll just see how it goes. I'm going to put a break in, and I understand if you got to go or just can't take it anymore. But there will be a break in the video, if not a split in the video. So you'll be able to see when I switch over and do some Project 3 work. Okay, anyway, Project 3 due on November 20th. And a heads up about that is that probably other classes, if you were taking them, also target that day to clear out some project work. And the reason why we do that is because we all want you to have the option to do Thanksgiving things if that's your choice to do so. And unfortunately, all of us doing that at once means that the work can pile up. So anyway, stay on top of that. That does make your Thanksgiving week a little bit less stressful if you use Thanksgiving to do anything with friends, family, or otherwise. I'm going to be in Project 3 later parts of the live stream today. Okay, we are the week of November 7. So we're actually not adding that much, but it's an important concept to understand. So I'm going to spend some time talking about what templates are, how do you create a template, what I consider to be some of the better and worse ways to go about implementing templates, because you can make templates that are difficult to compile. Or you can make templates that are easy to compile and highly distributable. So you probably already know where I lean just by the way I said that. So anyway, that's why there is a lot of stuff on today's agenda that talks about templates. actually, let's stop there and let's do project demos real quick. So I'll go quick as I dare to get through project 2 demos. And I don't remember why I picked these, but probably it looked good. I like this one, has this little summary at the top of it. So we'll just do most released. Very pretty output. So this is probably one of the people who collaborated on Piazza to get the file processing stuff perfect. So good on you for doing that, because this looks really, really good. And we'll go look at the summary data in floats. So when you are computing averages, they should be in floats. People don't expect averages to be truncated. If you are taking my assembly class, we truncate things because floats are hard to do at the assembly level, but everywhere else in your life, you should assume that when someone wants you to compute an average, that you compute it into a floating point number to show some precision about that value. So there were, probably like a half dozen people who did this as integers, which you shouldn't do. So you got a note from me about it if you did it. This person did it as floats, and that is good stuff. Okay, so there's number 1, number 2. So that's in my agenda also. If you compute averages, compute them as floats, unless you have any reason to not, other than just the lack of energy to do so. All right, so we'll just pick something. Calories. So this person went with a different output, which is perfectly fine. So there are the, what did I get? Lowest calories. They decided to put all the options in the menu. That's also fine. And then the summary. So I like the output. Here's one that did it as integers, and they will have gotten deducted some points for that. But anyway, I liked the approach, and that you can do different styling if you like to. So that one looked pretty good. Number 3. Here's a person who implemented, like I did, the ability to select the subset, like the lowest or highest up to 10. So I liked that approach. Nice formatting. Let's see the summary on this one. Also in floats, quite nice. So anyway, that was a good one. That was number 3. Number 4. But I can tell by Piazza that the people who had the good looking outputs put work into it. Which is, at the end of the day, what the good projects show is people who did work. This one has kind of a long output in it, so those kind of things I'd chop up roughly around 80 columns, which is also in the on my agenda, I think, because that was fairly common. So this person also had the picking the subset. Okay, yeah, it does clean up if I kind of scrub it over that way. So yes, go into the database. Oh yeah, this person did this. This is a cool touch. So this person actually allows you to look at the averages by restaurant, which once you have the data modeled, this is just work. So that was awesome. That's a very cool feature. And then there's the overall summaries. So that was pretty dang slick that person did the averages by restaurant in addition to the overall averages. So I scrubbed the names out of these things, but whoever did that was a cool touch. And I think you were the only person who had that touch. What's 5? Okay, so it's fat. 2, why not? Because I can do 2. The 2 most fatty items. Summary. This person got the summary worked out so that it's all lined up nicely using set width, set W. But anyway, if you Google how do I align output in C++, you will quickly find how that person did that. So nice work. All 5 of those are very nice work. So thank you for that. It helps my state of mind getting through the rough ones when I get to the good ones. So I appreciate that quite a lot. You'll see in the agenda that I have some kind of patterns that I noted. So when you're asked to compute an average, do it as a float unless you are directed specifically to not do that. When was the last time you saw an average that we don't sort of have the expectation that it's a floating point value? And that was just simply not putting the effort in to do that. So you can do it and you should do it. Long lines of source code, and I should have put also output. So if you are writing source code and it wraps around on the screen, you need to break it up. You either need to break it up into multiple statements or at least break it up by hitting enter somewhere in the middle of a list of arguments or something, and then lining things up vertically as opposed to just letting things spill over horizontally. The general rule of thumb is 80 columns wide. That's for source code and for program output. So if you're running over 80, that's a place to start looking for how can I break this up into more lines, output or source code. Source code style, so it's just a thing that I'm pointing out that some of you need to start paying attention to more carefully. One of these days, many of you are going to be out there looking to get into a programming team somewhere, and no one's going to want you on their team if your source code looks like slop. So you know what to do in your source code. You know what the alignment rules are. If you don't, Google source code style, and you will find many websites that talk about the sort of standard formats for doing that. If you've ever watched me in a live stream or a lecture, you'll notice that I take some care to make my source code look neat. And that's because it's more readable to me and to you. But more readable means something that other people would want to have anything to do with if they are choosing teammates at some software engineering firm. And then file naming. So it's just because I saw it enough times that I thought I'd make a note and say something about it. So generally speaking, yeah, if you have a .h file like mycode.h, you should not have the implementation in fuzzystuff.cpp. mycode.h fuzzystuff.cpp. It looks like a crazy person did that. And it also makes it difficult to hunt down things if someone is working through a large repository of code. Make those file names match in every way. The names, the spellings with the upper and lowercase, that should all match. It's just kind of odd, and you'll kick yourself at some point if you're not in better habits, because you will be involved in something larger, and you are either the source of other people's problems or you cause yourself problems just of your own making. So anyway, things to pay attention to. They do matter. Style matters. Naming style matters. The spacing of your source code, the alignment of your source code, the spacing and alignment of your outputs, all those things matter because they differentiate the people who are good engineers from the people who aren't. And you all can be and should endeavor to be the best engineers you can be, at least in my opinion. So there's my rant. Okay, so EdCast has a good question about my compute averages as float. So should they be floats when parsing? Not necessarily. So it's a very good question though. If my incoming data, if I know I'm going to compute averages out of it, should I convert my incoming data to floats? It depends. In this case, it would have been my judgment with the incoming data set that nothing was in floats in there, so I parsed it as integers like I received it. And then when I'm asked to present some summary information about it, I go ahead and just do the conversions to floats right there on the spot. Integer to float in C++ is very easy because if you assign an integer to a float, you get a float. So that would have been my judgment. But the important thing about your question, EdCast, is that sometimes you do have to make that call. if you are receiving a set of data and it's all integers and you're going to be doing lots of things that need the floats, then you probably want to parse them in as floats. But if you're receiving a set of data that's all integers and you just have this one place where you're doing floating point output, then typically I would opt for read as read as integer, present where required as float. Good question though. Okay, so back to template. Sorry, there's my sort of off on the side about project 2. Project 3, you're not going to have any, I won't show any demos because you don't have any choice about the output, which you'll see if you haven't read it already. So project 3 is entirely a technical challenge that you are asked to match the expected output format exactly. So there won't be any demos for that one. That was the last project, project 2, where you get to have some creative leeway in your outputs. You do have the ability to be creative about your algorithms if there's room that you find to do that. Okay, so the new content this week is templates. You should know what a template is. You should know where to find the standard library templates, and you should know you should know the syntax for creating a template of your own, in part because projects 3 and 4 require it, but also because you should know how they are creating code. So not a whole lot of readings. Lab 12, let me pop it open and I will come back to it. I don't think there's anything new in there other than the template part, but we'll double check before we move on to doubly linked lists. Okay, so we're exploring the keyword const. So in C++, const means a lot of different things in a lot of different contexts. So I wouldn't try to answer the entire question about const in all the different places you can use it in C++ and in all the different ways that it changes the meaning of things in C++. But we are focusing on the keyword const in C++, and turns out that there are a lot of different ways to use the keyword const. Where you place it in what context changes things. So what you're looking for is to sort of pick off one or help one of your classmates and just sort of expand on one use of the const keyword in C++. So one of them is to create a constant variable. So one of you will take that, but you will find that const appears in lots of other places. So that's your challenge, is to go hunt down where, why, and what is the meaning of the const keyword in C++ in all of the different places where it can appear. And then reminders, so lab and discussion as always, project 3 is out there. I'm going to go ahead and open it from here. Yeah. Okay. Templates. Yes, templates. So let me get C++ STL. So, well, yeah, let's use the Geeks for Geeks one. Let's use the C++ one. So templates in C++ is a way to create a function or a data structure that is unbound in terms of underlying data type, which is kind of weird. Those words probably sound strange, but the whole purpose of the technique is to create things that are more reusable because they can be reused with different types of data based on different contexts. Let me get that back up. Some languages call them generics. What C++ calls templates are called generics in other languages. I prefer the term generic because I think it explains, at least for me, better what the term means. So a generic data structure is a data structure that has the algorithms for managing a collection, and it is designed for a generic data type, meaning an unknown data type. In fact, meaning the data type doesn't matter. So I can create a struct, and I'll do it here in code in just a second, that doesn't care what its underlying data type actually is. But in C++, we call them templates. There is a huge library in C++ called the standard template library. You've actually used it in this class. that has a whole bunch of container classes that are all generic, or in C++ terminology, all templates. Let's see if we can, here's a list in the Geeks for Geeks style. So vector is a template class. We didn't use those terms necessarily, but when you declare a vector, you also have to say which data type to associate with that particular instance of a vector. And that's because vectors are designed to they don't care about the underlying data type at the end of the day, which is great because vectors can be used for strings, for integers, for my own custom types, for arrays of my own custom types, for vectors of other things. The vector itself doesn't care because the algorithms are just about managing the collection and they're not about the data that's inside of it. It's generic. The STL has a singly linked list, but it's one of the easier ones to do for ourselves, so we usually write one for ourselves so we know how they work. Double-ended queues. There is a standard template library arrays. So all of these things are generics or templates in C++, or at least have implementations that are generic in C++. Queue, priority queue, stack, maps are pretty useful. There's a lot. If I go to cplus.com, same kind of presentation. So we've used vector. And the whole trick that tells us it's a vector is, well, one, it says it's a template class. And then this kind of weird template-y looking syntax that precedes it. Just funny they use both terms. Just use one. It's either a generic or it's template. I don't know what a non-generic template would be in C++. But maybe there is such a thing, and I just haven't put the terms together that way in my own head. Okay, so templates in C++ are ways to create things like functions, like structs, like whole collections or data structures that are independent of any underlying data type. The reason why this is valuable is because we can create these collections and their supporting algorithms without having to worry about, wait, are you going to use a string in here or are you going to use an integer in here? It doesn't matter. You take my template or my generic collection and use it for whatever data type you have. I don't care. And you don't care. And you can use it and reuse it for all kinds of different data types. Okay, so that's what a template is. There's a little bit about the standard template library. Let's put one in a program. So you've seen this in the form of the vector. So vector is a collection or a container in C++'s standard template library. So when you see C++ STL, standard template library, what does that mean? It's a library of code for a variety of different generic containers. When you have a template type in C++, you have to, once you declare one, that's the moment that you tie it down to data. So here's where I have tied down my instance of a vector, which is called numbers, to the specific data type integers. So in your own code, vectors become ungeneric in a way because when you create them, you tie your specific instance to a specific underlying data type. I can make a vector of string. I can make a struct and make a vector to hold that. Ooh, I'll call it palette. This sounds fun. So in your experience, this is how you've seen templates in action. Pardon me. You've created instances of vectors and you have bound them, those specific instances, to specific data types. But that you can create instances to hold different kinds of data is a function of the fact that vectors are templates. generic types. So yeah, so there's the vector part. I'm going to comment those out so that they don't become a distraction. So that's all we mean by a vector. So now let's look at a simple example of creating one and what that looks like in code. So let's say we have a box and it's a string. I better get a string include in here. So we have a box and it's has some contents which are a string. So I can make a box. And populate it with string data, those contents. But templates give us the ability to create structures that don't care about their underlying data types. So the way I could convert this box to be a generic is by using the keyword template above it. And then I will say type name. Those are all C++ words. And then the common term thing to put here is a capital T. I could put anything that I wanted here. But you'll see people use T representing the unknown type. So template that is required in C++. This thing in square brackets is the placeholder for the name of the type that you will associate with an instance of a box. And then instead of only being able to hold strings, I will hold instead T's. So now I have a templated box which doesn't care what its contents are, whatever T is. So then let's go back and make an adjustment here in code. So how do I now use my template box if I want this string to go in here? Well, I simply say I want a box for string, which will be B1. Better run that, make sure I didn't make any errors. Okay. But now because the struct is a template, I can say, well, I want a box for int instead, B2. And now B2.contents would be a number. So this box maybe is not super useful this way, but the idea is that you can template many different kinds of things. You can also do this. And let's just do print an int, and then we will do B2's contents there. Hopefully I did that right. We're not going to do templated functions. I just wanted to point out to you that in C++, you can template functions, you can template structs, you can template classes, possibly other things. So here's a print function that will at least attempt to do an output on an item of whatever type you specify. And when it's a function, you tell the function that this is going to be used to print integers. And since B2's contents, by the way, notice I'm using kind of two layers of template here. Since B2's contents are integer, then this works. If I put B1's contents here, it won't work because B1 contents are strings, and I told the print function that I meant to be printing integers. I would have to change that. Okay, so there are some simple templates. We're going to do more complex ones here in a moment, but that's some simple ones. Okay, I'm going to go right to the lab code because I don't want to be on this so long that I can't do some decent stuff with Project 3. That's the basics of templates. The STL, the standard template library in C++, has numerous templated containers. They're all created in basically the same way. Name of the container, the alligators to specify the type name for this specific instance, and then the name of the instance itself. And now you have, in this case, a thing that will manage integers. In the case of messages, a thing that will manage strings. Well, palette wouldn't work anymore, by the way. This won't work because you have to say what kinds of boxes, since they're templated too. So let's say boxes of integers. I think C++ will let you butt these up against each other anymore. Let's see. You didn't used to be able to get away with it. No, it didn't. Got to put a space in there. So I might as well put a space in both. Wait, what? Oh, I commented out vector. So maybe I can. Let's see if it'll work without spaces. I think maybe the compilers will do it now. Yeah, okay, it did. It's just hard to read. All right, anyway, so standard template library. I encourage you to go explore it and try things in it. Vectors, super handy. Stack, super handy. Queues, super handy. List, super handy. Map, super handy. There are a lot. You can go to c++.com. This containers page, standard containers, and then there's just a whole bunch of them. Or I Googled to get to this Geeks for Geeks page that has the same ones. And then presumably if I click this link, it'll take me to a page that describes how to use it. Yeah, it does. So there you go. Standard template library, templates, and creating my own, in this case, a templated struct and a templated function. But now we want to look at an entire templated class. So I'm actually going to do I want to spend time on that? No, I don't. Let me get lab 3 in here so that we can look at it that way. Wait, let me see what state lab 3 finds itself in. Yeah, lab 3 is already too far along. Let's do our own just to be sure. Okay, so I'm going to make a templated class here. And I'll just box.h. And then I'll make also a box.cpp. So where I'm at in the agenda is we are going to create a class that's templated. And then I'm going to show you the different ways that people implement these things. I'll go from what I consider to be the most awkward to the least awkward way of doing this. So the last thing that I will do will be the one that I recommend for ease of use and portability. So let's comment out all this crud. Don't need any of that stuff, but I will leave this to where you guys can get to it. So I'm just commenting things out. So I have less mess to deal with. All right, so we'll put it here. Okay, so let's make a whole class for a box. So pragma once. Only on the .h file do you do pragma statements. So one person put a pragma statement inside their CPP file, which generally speaking doesn't usually make any sense to do. So CPP files are compiler level things, which means that it would be difficult to cause them to be processed more than once unless you had a very bad setup. But header files, on the other hand, which is where I'm at, box.h, header files, every time you have an include statement for a header file, you have the possibility that you're going to ask the compiler to go read the definitions more than once. So pragma once tells the compiler, if you've already read these declarations, you don't need to read them again. Because if you cause declarations to be read twice, it's like having duplicate variables and you get an error. So pragma once just ensures that the compiler only reads the declarations for box.h one time. And that's only an issue because of the include statement for box.h, which may appear in multiple locations. And in fact, in this program, it won't in this program, but it could. All right, so pragma once, where? Only in the header file. Includes, only in the header file. You should not have library includes in the .cpp file. The only include that you should ever find in a CPP file is its own header file. Everything else that you do for includes should be in the header file. Why? Because the header file is kind of the documentation. It's the beginning point for other programmers to know what your code is and how to use it. Programmers shouldn't have any need to open up your CPP file because they don't care about the details as long as the details work. So you want to use your .h files to document your code, which means everything that's declared in there, all of the signatures for your functions, meaning their return types, their names, and their arguments, your includes, your library dependencies, those go in your header file so that you can communicate to other programmers what libraries you are dependent upon in this code. There's no reason to have any of that stuff in the .cpp file. And if you put it in the .cpp file, you are making it harder for other people to find your documentation. So just don't do it. Don't get in the habit of it. All right. I don't know what includes I'm going to need just yet, so I'll wait and see what I use this box for. But we know we're going to make a template. The T is completely optional. I can use whatever identifier I want there, but everybody in the world uses T, so you should, so that you and everyone else recognizes when they see that T sitting there by itself, what it likely means. So let's do a box this time. Oh, no, let's make it interesting. So why is my include for vector here? Because it documents the fact that I need and use vectors so that when other programmers open my header file, they don't have to go fishing around for what are his dependencies. They're sitting right here at the top of the header file, and that's as far as they should ever have to go to know how to use my code. So I am not putting include vector in box.cpp because I don't need to, and that just makes life harder for everybody. Okay, class box. Set up to have public ones, private ones. Let's put a vector in here so that you can see for the first time one of the uses of the template. So if the box is going to hold a generic type T, what that really means is that it is going to offer functions to access and use a vector of that same type T. So declaring a box of type T means that the box will be managing a vector of type T. We don't know what the type T is yet. I'll call that the contents. And then we're going to have things like this. Void add contents. What type are the contents I would be adding? They are T's. I don't know. They're the generic type that I don't know as I'm programming this template. I just have to allow that they will be whatever type someone wants. I will call this a C. No, I could, yeah, I'll just do that. Add contents, get contents. Oops, that's going to return a T. I'm just going to do by indexes, so get the contents at an index. Add contents, get contents. That's enough. That's enough for the example, I believe. It's enough for the example. So I want you to see where in the box I've actually sort of carried the templated type forward. So if the box is templated to the as yet unspecified type T, what does that mean? It means that I am going to be managing a vector of that same type T, unspecified as of yet. That means that when I add contents, I will be adding content of a type T. And when I get contents, I will be getting contents of a type T. Okay, so that's step one. Here's step two, is to implement these functions. So this I consider to be the least nice way to do this. But you can implement these things in a separate file, but notice that I have to carry the template argument forward with me. So it would be this contents dot push back content. So I personally do not like this style. Box. I'm not doing any arrow checking. I wanted you to see this style of programming. And let me see if this just works out of the box. It may or may not. Let me go ahead and include box.h. So note, yeah. And then let's see if we can make a box of int. And let's add some. Should be able to do that, but let's see. Okay, good, it didn't. I know it sounds odd that I just said that. So templates are a pain in the butt to compile because this making a box for integer means effectively that the compiler has to take all of that box code and do a conversion on it so that all the t's become integer at compile time. So I'm not going to go a whole lot further into it other than to say that it's complicated for the compiler to deal with templates, at least in theory. So right now it's not compiling, and that's because a lot of compilers just don't like dealing with templates because they've got to load in all this code and sort of make conversions as it's being compiled to actually fit a B1 to specifically integers. Okay, so how do we fix this problem? So we're going to go to box.h. We're going to go to the bottom of box.h, and we're going to do something that I hate, which is to carry forward from box.h into box.cpp, which means that we will then get rid of the include because we're just more or less, the act of including box.h is going to include all the declarations and then carry right forward into the implementation. This is ugly, and you should not do this except in the case of templates, and even then I would argue against this approach because I just don't like it. But let's see if this will build with that new approach. Still is complaining at me. Box is not a class namespace or enumeration. Yes, it is. Class box. Note box declared here, yes. Do I have to do the include twice? That cannot be so. Let's try it. And it's possible also that, no, because I had box.h before and it wouldn't compile, which is okay. There's actually more errors now because of the extra read through, interestingly enough. Okay, so anyway, this particular setup in REPL, I'm not seeing a way to get it to work. It just doesn't work. And I don't see that I've made any mistakes. It just, the compiler does not like this particular arrangement of goodies. There's box.cpp. If I take the include out, because technically you don't need it. I templated both functions. Yeah, it's still just box is not a class namespace or enumeration. All right, so you can just see how kind of kooky this is. So how do people solve this problem when they can't get a template to compile? There you are, box. There's the include for box.h, which is totally just right there. Um, has a pragma at the top of it, but that should be fine. Okay, so what's the problem? Well, let's try the second approach. So some people fight with this and get it working, but I do this instead. The second approach is to get rid of the CPP file entirely. And put all these definitions in the .h file itself. Now I'm going to get rid of the CPP file entirely. So now I have box.h, and it has the class at the top, up here, and then below it are the full implementations with all the templated stuff added in. Let's see if that will compile. Maybe I have made a mistake. What in the heck are you talking about? Box is not a class, namespace, or enumeration. I beg to differ. Anyway, I'm still fighting the compiler, as you can see. That should work, but I fought with these in the past, so it could be the way the Replic's makefile is working. Let me go back. Let's do a manual compile. I'm glad you're seeing this, though, because you're seeing the battles that I have fought in the past that have led me to the way that I do templates. So let's see. There. Let's see if I put this back. And just do a, let's see if I can do a manual compile box.cpp here. Yeah, template. Oh, shoot. Now I see the error. No, I don't. No, good question. So the question from in chat is, am I missing a semicolon anywhere? I don't believe so. Oh, now I see it. Now the compiler has told me what it is. It's this. Ugh. Yuck-y. Okay, let's see if that gets it to compile. Box T get contents. What? Wait. Oh yeah, I have this. Sorry. I have the extra include. Wait, how does that work? Well, let's see if it'll run with my little fix. No. No template named box. Okay, anyway, you have seen the kinds of battles that I have fought before, and why I do it the way that I do it. So anyway, there is a way to get this to work. I just I don't use this anymore, and this should work in theory, though. I'm not sure what I'm missing in the arguments here. Template type name. T, that's all good. Void box of T, add contents, box of T, get contents. I'm seeing these makefile errors, which makes me suspicious about the cause of the thing. Include box.h. Anyway, you can all tell that I'm fighting the compiler to get this thing to compile. So let's try to put these back and see if the stupid thing will compile. In this format. Okay, it does finally compile. So anyway, you've just seen me where I tried to separate out the implementation from the header file with a template specifically. And it fought me just all kinds of everywheres. Just fought me like crazy. So now I have put the implementation in here while remembering that the box references have to be templated, and isn't this just a terrible, terrible mess? So what you're looking at is the separate files. I couldn't get it to compile in REPL. So I gave up and I got rid of the separate .cpp file. I put the implementations down here with the little fix on box, and now it will build. But even this, I just consider to be a horrible, horrible mess. So what is in my opinion, the best, most cleanest way to do this and also gives you the advantage of having all of the template code in one place so that you can distribute it easily. Simply do this. For templates specifically, just put the implementation in the actual header part. So now that's the whole file. I don't have to do any weird extra syntax with the scope resolution and the box alligator's T at the bottom of the file. I don't have to repeat the template line over and over again. I don't have to fight compiler battles to try to get the implementation separated out. With templates, I have found that this is by far the easiest, cleanest, and most portable way to do it. Simply just embed the template code, the implementation, in the class header itself, and life is so much easier. And you'll see other people do this as well. When we do this, wait, let me make sure it runs. All right, when we do this, we should not say box.h, which implies declarations only, but actually name it HPP, which communicates to people that this is a header with implementation in it. You may, I don't know if doctest.h, does it do .hpp? I can't remember. I don't remember. But anyway, so I named it .hpp because as a template, I put the entire implementation in the header file, and I put actually the entire implementation in the header. The class declaration is also now its implementation. This is okay by me in practice for templates and not for many other things. Because I think if you can kind of easily separate the implementation out, you should. Because HPP files can be hard to read, which is where other programmers are going to go to look through your code and see what it does. But in the case of a template where you are offering this generic type, and you may end up having to fight compiler battles or cause other programmers to fight compiler battles, I personally believe that this is a good place to do this style of programming. So it's a template, and I don't want myself or other people to fight compiler battles because it's a template. I like this style. I also think it's relatively clean to look at without all the extra alligators and all the extra template lines and all that mess. So there's my case. I think that this is the best way to do it for templates because of all of the issues that you've now seen me battle with just to get this far. The include, by the way, should be HPP. And now we're all happy with the templated box with its inside the header implementation. Okay, so that's that. I will share that now, kind of missing some parts, but still I'll share this REPL so you can play around in it if you want. But for the earlier mess, you'll just have to kind of see the lecture. That's correct. So Tony asked, and it's a very good follow-up question. So do I need a box.cpp file somewhere or do I not? And so no, I just dispense with the whole box.cpp. I just throw it away. Everything is in the .hpp. Great question to follow up on that. No more box.cpp anywhere. Okay, so where are we at? Okay, we're actually doing okay on time where I might be able to do some Project 3 inside of our hour and a half. Let me go fire up a... where's the create button? Oh, whatever. Let me fire up a lab 12. So there's not much for me to show you here other than to make sure that there's not anything spectacularly new going on, but let's look at it. and just be sure. Okay, so what's going on here? We are converting our singly linked list into a template. That means that when we have references to the data type somewhere, we need to make sure that we refer to the data type as a T. Notice, by the way, that the node, well, it's empty. That's good. So what did we have in a node? We had a pointer to the next one, and we also had data. I can't remember what I called it. Oh, value. So notice what I did with the node. I made it the templated T value because that's where kind of the template type pushes forward into my linked list. That's what the nodes are going to have in them, just like my box. It's going to have some unknown data type. This changes the constructor for the node as well, because now we're going to be getting a T, and we will say next equals null pointer, and this value equals value. The important thing there is that the constructor, in referring to the value's data type, refers to it as a T. So be very, very careful about the node on lab 12. I think I said lab 3, lab 12, that the value in the node is the templated type T, because we don't know what it is anymore. It's inside of a template. Where else does this matter? Here's a place where it matters, but it's already been done for us, is the T. Fortunately, for push front as an example, we just say node star n equals new node of value, and the T part just kind of takes care of itself. So the code in these places shouldn't really change anywhere, I don't think, right? So if this head equals null pointer, this is front. Let's just see if the T that we return has any impact on the code that I have to write in the implementation. Then I will throw a standard logic error that says empty list in it. Else I will return this head value. It doesn't. The T doesn't affect the code inside of the function block because this head value already is whatever T is. We don't know, but it doesn't matter because it doesn't affect the implementation of the function. So be on the lookout for that, but I don't think it affects anything. The constructor just sets head to null and size to 0. The destructor calls clear, nothing to do with the T or the value. Push front already is set up to understand that value is templated type, unknown, and then it doesn't affect the code. Pop front is going to have nothing to do with the templated T. Here's the templated T on front, but it turns out that in the implementation it didn't do anything. The value is whatever type it is for this list. Get size not affected, empty not affected, clear not affected, to string shouldn't be affected because we're just printing out value. So I don't think T comes up here either. And then I believe, you'll have to double check me, but I believe I just finished the node where I accounted for each node having a templated or generic T data type for its value. And then in its constructor, also the generic or templated T data type of unknown type until runtime. Okay, that is lab, pop my back. That's lab 12. So what are we doing? We are converting the linked list. Hey, wait a second. I did this in the wrong place, didn't I? Should be in slist.hpp. Because it is a header-only template, meaning that the declarations, the headers, and the implementations are all here present in this one .hpp file. So that should be the only thing we have in here. Was that .h? Oh yeah, I did call it slist.hpp. Yeah, I just forgot to create it in the REPL. So now I have it. All right, so there's the one time we have to use template because we're doing it an in the header implementation. And then the function implementations themselves are all in the header. That's on purpose because templates are nasty to deal with. There's nothing below the class declaration, and there's no separate .cpp file. Okay, I think that's everything for lab 12. There are no new functions, so if you have a completed lab 11, then you've already written all the implementations. You just have to move them over to this new one and put them in their right place, and then click run, and it should just work once you have converted it to be a template. Okay, so I'm going to put a break in here. Maybe I'll put, it's 11:01, so I'll put 3 minutes. So I'll come back at 11:04, and I'm going to put a break screen. I'll be right back. And when I come back, we are going to work on some project 3. I'm going to help you get started on project 3, including some of the algorithms that will be required. So let's do that at 11:04. Be right back. Getting water, getting up to stretch my legs, that kind of stuff. Okay, so project 3 stuff. And if you look on the home page, this is where the doubly linked list note comes into play. So I've got my drawn thing out because we're going to, for project 3, we're going to make a better linked list. We're going to make a doubly linked list, one that goes in both directions. Okay, so I'm going to just read the description. So for this project, we're implementing a templated, so we'll have some HPP file somewhere, doubly linked list. Instead of unit testing it, we are going to feed it a series of commands from an input file, which will cause different behaviors to happen. All right, so we've got an input file that has commands in it that we'll have to parse. The end result will be a screen that contains a bunch of outputs. And what will happen then when your program is completed on project 3, what I will do is I will run it, and I will take your outputs and compare them to my expected outputs, and I will find the bugs by where your outputs are different from my own. You have samples for this. Well, did I pull that up yet? I don't think I did. There are samples so that you can see some sample inputs and their sample outputs that go with them, which we'll look at here in a moment. So we're doing a doubling linked list in a template. So it's 2 links on every node, and that's more complicated because you have to deal with a lot more links in your algorithms. But it does give us the power to add and remove from both ends of the list whenever we want. All right, so we'll parse commands. We will map the commands to calls on our linked list, and then we will produce outputs as directed. Templated doubling linked list, a driver, the usual usage and file can't be open messages because we're going to be using input files. Okay, here's the repo. So we'll go look at that in just a moment. All right, so anyway, here's what mine looks like at runtime. The usual, I tried to run it with no arguments and got a usage message. I tried to run it with a non-existent file and got an error message. And then I ran it with a correct input file and got a set of outputs that are exactly as the specification says they should be. Spacing, spelling, everything is exactly the same. All right, so that's kind of the challenge before us, is the linked list and the driver that will load the commands and make sure that the right calls on the linked list are executed and that the right outputs are produced. And here's all we have for inputs and outputs, and then a sample of both. So once you get yours implemented, you can feed these sample inputs into it and then compare your outputs against mine, and they should match literally exactly down to the individual character. And next week I'll show you how to do that. But let's look at the required operations and start making a shopping list for ourselves. Some of these are user interface and some of these are linked list operations. So I'm going to go ahead and copy these. And I'm going to fire up a REPL for myself. And for now, I'm going to make myself a notes.txt file, which I can do because the compiler won't care. And then I have these as a reference point for what kinds of things I'm expected to build. So ignoring comments, that's a file parsing issue. Creating an instance of a list, that's a driver issue. Clearing a list is a list issue. So I need the ability to clear a list. Deleting a list is a driver issue. Inserting, which means that we're going to actually make linked lists that are sorted. Adding numbers to the front, adding numbers to the back. Removing all occurrences of a number from a list. Removing the first occurrence. This will be interesting. So there's a lot of list operations in here. Print all items in the list. The size of the list, those are easy. Popping at both ends. Getting the contents at both ends. That's probably where we will start, is fronting, adding something to the front, add something to the back, pop the front, pop the back, return the size, print all items in the list. All right, so this is just kind of a quick review of what my functions are supposed to represent. And I'm going to have to kind of figure out which ones of these are linked list operations and which one of these are driver operations. So comments, that's a driver operation. Creating instances of a list, well, lists don't create instances of themselves, so that's a driver operation. Clearing a list is a list operation. Deleting a dynamic list instance That's a driver operation because lists don't delete themselves. And then I suspect the rest of them are all list stuff. Okay, so anyway, that's the required operations. The required outputs shows me the formatting that goes with the various commands. So you can do this how you want to, but I'm probably going to, every time I implement something, I might just kind of quickly implement the file parsing and then add that command in and then its output. So that's probably what I'm going to do. And we might start with something like, if a list instance already exists, delete it first. Okay. So anyway, these are what the formatting are supposed to be for the outputs that I produce. So I have the required operations. That's going to affect what functions I write in my code. I have the required outputs. That affects the outputs that I do in my driver. I need a doubly linked list, which is what most of those functions go with. And then I need a driver, which is where all the outputs and then the controls on the list itself will happen. Okay, so I have my notes. I'm not going to bring these outputs over. I'm going to bring them into my notes one at a time as I implement them. So let's go to main. So I know, for example, that I'm going to have to open a file. And I'm going to be formal about this. So I'm going to want the couts. I'm going to want the end lines probably. I'm going to want the input file stream. That's all I can think of right now. I'm going to want the int argc char star or the array thing. So if argc is not equal to 2, we already know all that stuff. Else, so now I attempt to open. And I can already test this. And this is what I recommend that you do. Test this thing. I'm going to go fast through the stuff that you should already know how to do. So there's my usage message. Great. I've already got that working. I don't have to worry about it anymore. Should also be true that if I put in a non-existent file, perfect. I've already done that stuff. I can move on to other things. I can even fold them because... well, I might not, let me get this set up first. Okay, so now I have the not good. I have the not argc, and wait, why did it do that? Yeah, like that. That looks like crud. I don't like it. Oh, I'll just leave it. I'm not happy with it. But anyway, so here I am. If it's not good, well, else means it was good. So now I can start processing the file. So string. I'm going to call them commands this time. Command, while, get line, file, command, if. Might as well check for empty lines, even though I wasn't told I needed to do so, but why not just do it? So if file, oh wait, no. The command is not empty, and all right, so now I've already taken care of empty lines and the comments, and I've already got some of the requirements knocked out. For now, I'm just going to say cout command, turn out the command and an end line. And then I'm just going to take one. That's from my notes. I'm going to put it in a file like this C and see what it looks like. So easy enough. Let me make an input file and put a C in there. Actually, I'll even put a blank line in another one just for the heck of it. So I should only see the create command coming through. I need an include for string. I wish you could fold the includes. That would be handy. How am I doing on time? I'm doing all right on time. Okay, so we already know that. Let's just run it against the input file. All right, so I got a command, and it ignored all the other stuff. So I'm doing this in part because this approach works for me, and I think it'll work for many of you as well. Tiny steps. Do a thing. Run it. Test it. Do another thing. Run it. Test it. I'm never at a point where, at this point, the only thing that should break is the next new thing that I try. And I'm going to take baby steps. So baby steps, baby steps. Let's make the template for the doubly linked list because we want to be able to create one in our program. So here we go. dlist.hpp. I know it's going to be a template, which means that I know that my life is going to be easier if I just do the entire header implementation all in one place together. That'll make life so much easier to do it that way. Okay, so I'm going to do a pragma here. Template, type name T, class dlists. Seems adequate. And that's it for now. I mean, I can put public and private in there, I guess. Okay, so now I have one. I'm going to go to main. I'm going to include it. I'm going to put it at the very top. Some kind of star billing. dlist.hpp. Okay, so why is this in here? Because in this section of the program, we got the file open. Let's do work on a linked list. So we're going to start by giving ourselves one to work with. And because it says, if I go to the notes, create a dynamic list instance. So that word dynamic tells me I'm going to have to do pointers here. Because I have create a dynamic instance, delete a dynamic instance. So the instance of the linked list has to be dynamic, which tells me in my driver, main.cpp, that this thing right here needs to be dynamic, but initially it's not going to exist. I'll build it like this. All right, so there's my linked list, which does not exist. Why didn't I just create one to start? Because one of the commands says create one to start. So if one of the commands is the ability to create one, then I need to have it be non-existent sometimes. So I'm just going to start non-existent. And then instead of, well, I guess I can print out the command, but now I will start handling the command. So I'm going to do it by dealing with the first character. So if the command at 0 is create, I don't have to be case insensitive here. It tells me in that these are the commands. So I'm not going to worry about being case insensitive. You can if you want, but I shouldn't see any commands like that. So if it's a C, then what do I do? All right, now I have to start looking around a little bit. So the notes just say create a dynamic list instance, but I also have the outputs file that has an extra note on it. So I am supposed to say list created, but also if an instance already exists, delete it first. Well, I know how to do that. So if the command is create, the first thing that has to happen is I have to ask the question is the list already up and running? I.e., is that pointer not null? If it is, then I need to delete the current one. I'll go ahead and null it out just to be on the safe side before I do anything else. There's no else part here. The command is create. I'm just going to check first. If there's already one here, I'm going to get rid of it before I make a new one. And then I'm also supposed to say list created. Let me double check the output. List created. If an instance already exists, delete it first. All right, so I did that. There's my whole Command C sequence. I'm going to put 2 end lines here so it's separate. All right, let's see if that works. Am I having a spelling? Oh yeah, dummy. dlist is a template. I got to have a type. So what types of data are we talking about here? Let's see if the project says. All right, let's see what the input files say. Integers. I probably should have written that somewhere, but now that I'm just telling you, I guess I don't have to anymore. Integers. Okay, so the input files are going to want a dynamically linked list for integers. So when I declare it, it's going to be a list for integers, and when I create it, that's the other place where I have to say I'm creating a new list for integers, and then we should be good to go. Oops. All right, list created. We're getting on a roll here. What came next? I guess it's easier to have all 3 of these kind of, so having these notes separate from the outputs is helpful. So I can kind of have them both open at one time and then switch between them. It's created, list cleared. I don't have code for that yet. I can handle list deleted, but you know how to do that. So yeah, let's do some list stuff now. All right, so here's my D list. We know it's going to have a size, and it's going to have a node in it. And it's going to have 2 pointers, and this is going to look funny at first. It's going to have a pointer to a head and a pointer to a tail, at which point I got to go draw pictures for a bit. So we haven't finished the node, but we need 2 pointers for a doubly linked list because we're managing a thing that goes in 2 directions. So let me now switch and show you a picture of what I'm talking about. Okay, so a doubly linked list is going to look like this. Here's what one will look like after it's been up and running for a while. And these will be pointing off to null pointer. So this is what a list will look like, a doubly linked list. Doubly linked, why? Because every node has 2 links, double links. One link that goes to the next one down if you're going from left to right, and one link that goes back to the previous node, which is sort of right to left. And then you'll notice that we have 2 sentinels on a doubly linked list. We have a head sentinel that keeps track of the front one. We have a tail sentinel that keeps track of the back one. And then we also have the front one. Its previous pointer goes out to null, and the back one, the tail, its next pointer goes out to null. So if we have a linked list to start, it's going to look like this. Where the head and the tail both just point to null because there's nothing there. Once we get a node in a linked list, however, then there is going to be this weird situation where head and tail point to the same node when there's only one in there, because it is both the head and the tail. Now, the fact that there are heads and tails, there's always a head and a tail, complicates some of the algorithms. Because if we remove this one node, then we have to make sure that head and tail both become null when this single alone node gets removed. And if we add a node to the front or the back, and there's nothing there, then we have to make sure that as a consequence, the head and the tail both point to it. So I'm going to begin to develop some of these algorithms, and then I'll switch back and we'll see. I'll try to call your attention to where it's easy to make mistakes. The difficult algorithm. There's two difficult algorithms. Inserting something in between, which we can now do. It's kind of more practical to insert something between nodes in a doubly linked list. So we're going to be inserting nodes in between. And we're also going to be removing nodes from out in the middle. And those are complicated algorithms, which I hope I will make time to cover both of those before the project comes due. Okay, so here we go. What does some of that look like in code? All right, so I got my dllist.hpp. So a node, what does it have in it? It has a value in it, which is of the templated type T. Notice we're doing everything in the class header, just like we did a singly linked list. Now we have two pointers. We have one going to the next one, but now since this is a doubly linked list, we're going to have one that goes back to the previous one. And let's go ahead and make a constructor, because that makes life so much easier. If we have a constructor here, which assigns the proper value into the node and sets next and previous to null. Some people don't like this practice. I like it just fine, since C++ works its way from right to left. I'll assign null to previous, and then now that previous is null, when it's assigned to next, they'll both be null. So I want to make sure that that node, when I create it, is all nulled out in both directions. I'm not going to draw a picture of that, because that probably does make some kind of sense. Okay. So dlist. Yeah, dlist needs to do something as well, doesn't it? The dlist constructor needs to make sure that the size is 0. Oh wait, I forgot to do this is on this, so it should be consistent. And then this head equals this tail equals, both of them are null, and we'll make the size be 0. All right, so now we have an initialized doubly linked list. That's the picture I drew where head and tail both point to null. The size is 0. And then we have this node struct, which we will use to create our nodes. And then we also have a pointer, a special pointer to the head node, and a special pointer to the tail node. Okay, let's see what the notes say about, let's do a front. Okay, so it'll be F followed by a number. Oh, it says number here. I guess I could have figured it out from there. Insert a, oh wait, no, we want F. F. Add a number to the front. Okay, so I'm going to go ahead and add that as a command. I'll just say 10 to start. Right now, if I run my program on it, There's the command, but I don't have the logic to handle it yet. So that's okay. I'm just pointing that out. Eventually, I'll take the command output away because that will muddy my outputs. But for testing purpose, in fact, you know what I should do? I shouldn't put this extra new line here. I should put it here. That way I print the command itself and then print the resultant action for now. Okay. So it'll be F followed by a number is add number to the front of the list. Got it. So I'm going to go up to the public section of my dlist class and I'm going to add a push front. The common terminology here is push front and push back. But you've seen push back with vectors as an example. So we say push front. So push front will come in at the head sentinel and push back will come in at the tail sentinel. What are we pushing? A value of an unknown type t. Okay, so push front a t value. We first make a node to hold it. You might notice that so far nothing looks the same from our singly linked list. So let's just see what happens if we follow the same steps as our singly linked list. So we hook this guy up and next equals this head. This head equals n. And then this size plus plus. So let's see what this looks like if I draw a picture of this algorithm on my doubly linked list. And I know I'm going over. I'll probably do a remove back, and that should give you push back and pop back. And then I'll stop for the day. Okay, so pictures. We have this thing. Head pointing to nothing and tail pointing to nothing. Oh, look. In fact, I'll just null, and then I'll tear this in half and I'll have that to use in a moment. Sweet. Okay, so this is our situation. We just made a node, which is n. We're going to put some value in it. My test input is a 10, and then it is making these both be null. Okay, so what did I do? I made the node. Node n equals new node, which I know takes the value, nulls out the pointers. So then I did this next, previous. This next equals head, which is null, so that's fine. Right, yeah, so this next equals this head, which is null. And then I said head equals and I pointed head at the same place that n is pointed at. So I got a problem here because the tail pointer is still pointing at null. And it can't because I have a node. It's both the head and the tail at the same time. So I missed a step. The tail should also point to the new node. So let's go do that, and then we will try to add another one and see what the implications are. So I forgot this part. To hook up the new thing. So now I have hooked it up. So that all looks right. This n will go away. And then I have my one node list. All right, we still have problems though. So let's try it on another example. So now I have this list. And then let's say that I add another node. So let's just say I add node 5. So if I add a node 5, it's going to be created like this. So what my algorithm does is it creates this node in, and then it says this next equals head. All right, that seems okay. This head equals next is fine. This head equals n. That's fine. But then it says this tail equals the new node. And that's a problem because 10 is still the tail. Even though I have a new head, I shouldn't be moving the tail over here. So that's a special situation. If the tail is already pointing to somebody, don't move it. So how does that look like in code? So I just discovered that I shouldn't just always move the tail. That's only when the tail's not pointing at somebody. So I should say if the tail is not pointing at anybody, then point it at this one. So this is going to be where the doubly linked list is more challenging, is because we're going to have one-off situations like this that we're going to have to detect and handle. So when the tail is null, it was fine to point it at this node because it wasn't pointing at anything otherwise. But when the tail is not null, I don't want to move it because I will lose whatever happens to be the tail presently. So in theory, we can do a get size. Let's do a get size. Which would at least be a crude way of knowing if the list got nodes in it. And then we'll do a couple of push fronts. So go to my input. I'll do another 5. And then what's the command for the size? Here it is. It's n. Okay, so an n. In fact, let's do an n before we start adding anything, and then we'll do an n after, which should be 2. Now I'm going to go look at the output requirement. So here's the f command, value n added to head. Ooh, I got work to do on that side, don't I? Value n added to head. And then list size is n. Okay. So now I got to go do some driver work. So else if command.at 0 is n, I will say list size is, double check that. Yeah. List, it's a pointer, get size, and an end line. Okay. Now I have the harder one. Because the F is carrying additional information on it, much to my chagrin. The F has this number at the end of it, which means I got to go get that thing off of it. So I'm going to take as long as the commands are only one character, then I don't really have a complicated parsing job here. Because all I really have to do is, I got to get it. So I need to say int n equals. I can take the command. I can grab a substring off of it. I can start at position 2, which cuts off the command character and the space. So I'll just grab everything from position 2, which is the third character over. So for F space 10, substring 2 is the 10 part. Oh, and all I have to do there is say string to integer. And I should have an integer. Now I can say list push front n, and then I have an output I'm supposed to do, which is value n added to head. Sorry, value n added to head. Value n added to head. All right, let's try that out. Node start next. What? I broke something, or I forgot a template-y bit or something. Don't tell me I got to template these things up. I doubt that. Let me see. That, well, if I do, I do. It don't feel right, but let's try it. Yeah, that weren't it. Oh, because I have this. Oh, you know what? I bet I don't need these. Let me take these off. I bet where I need it is up in the one function that creates a node. No, pushback will do the same thing. So I think I need to make note of the template type here, although I'm surprised I have to do that. Yeah, that shouldn't have been. That should just not be. Let me look at the error more carefully. Hold on. Forgot about you. What? Line 28. Oh my goodness. No one caught me. That would be a struct. So no, yeah. I thought like the extra template-y stuff was bad. So the node just has to be you have to tell it it's a struct. No weird template-y stuff there, and also no weird template-y stuff here. That should be one of the advantages and is of doing an all header kind of thing. Input.txt. List size is 0. Value 10 added to head. Value 5 added to head. List size is 2. Where am I at? I get done in less than 7 minutes. What else should I do? That's a fair amount. Guess we should pop front probably, so that I have time to do the more complicated ones next week. Okay, yeah, so let's look at the notes. I saw something in the output file. Yeah. Any operation executed when the dynamic list is null, with the exception of C, should print a message. So in other words, you can't get the size of a non-existent list, and you can't add items to the front. So you're supposed to actually print a message saying, hey, you got to create something, unless they're using Command C. So let's deal with that. That's a driver issue. So if the command is C, everything is fine. The problem is anything that's not the command C and we'll just use the decision tree to kind of, so it's going to look weird, but we handle the command C. It doesn't need anybody's help. But after the command C, then the first thing we'll do in our tree is make sure that we're not dealing with a null. So must create list instance. And now let's try, in the input, let's try to get the size before we've created one, and we should see that message. Except for I have to run it manually, which is going to be a pain in my rear. Yeah, so there's a must create list instance. So, and then otherwise everybody seemed to be happy. Okay, so I hope that you're getting like totally loaded up on how you're going to go about this project. Yeah, I just got to do it. So I apologize, and I thank you if you're sticking through it this long without taking a break. The people who consume it as a video, I guess, have the advantage of stopping and getting up whenever they want. But let's go ahead and finish the thought, and let's get a pop front. So the pop front command is T, a T. So in my input, I would put a T, and why not put a size right after that and see if that works. So I'll implement the pop front. I also should refer to the outputs and see if there is any problem. Yeah. So removed tail or print empty list. Oh wait, removed head or print empty list. All right, so I'm going to use our experience from the last 2 weeks plus this week on pop front. I'm going to need finally an include standard accept, and I'm going to actually implement my pop front like we've been doing. So void pop front, no except false. It can throw an exception if this head equals null. That's a problem. I will throw a standard logic error empty list. Now I am being careful here. I'm kind of cheating a little bit, but I'm going to make sure that the exceptions message matches the output required. Although technically it doesn't have to. Technically it doesn't have to, but anyway. So else. Okay, so popping the front. If there's nothing there, we've already got that. Popping the front is basically that we do give ourselves a temp head. We will say this head equals this head. Next, move it over one, and then we will delete temp. And let's see in the weirdnesses of doubly linked lists if that is going to be okay. So for a delete, we will take a temp and point it here. And then we will say move head over one. And then we delete. I just saw another problem from push front. This guy right here. We got a push front problem to fix before we finish this. There's a dangling pointer on push front. Let's go fix it. Push front. Yeah, so when the tail was not null, we needed to say this tail previous equals n. When the tail was not null, that was a thing to handle. So going back to the insert, we said if this tail is null, go ahead and point it, but if it's not, don't touch it. But if the tail is not null, then we have this node here who has a previous linker that needs to go to the new guy. So we just made this connection when there was already a tail sitting there. All right, so, but now we can come back to the pop because we moved head over, but now we've got So deleting this node, that's all fine and good, but it's the same darned link that used to go here that should now go to null. So yeah, bummer. More complicated. This will need some debugging, and I'll have to go over it, and hopefully someone will test this out in the meantime and find bugs for us all. Let's see, pop front. Yeah, so if I move the head over, then I have to also say now null. Crazy stuff. It's a lot to keep up with. And even then, there's still a problem. So that nulls out this guy. We move the head over. We null out this guy, so he's no longer referring to the one we want to delete. But that does not handle this problem. What if it's the only node? So we get a temp. We move the head over, which moves it to nothing. But we didn't do tail. So if the head moves to nothing, the tail should also move to nothing. So right here, if the head moves to nothing, then the tail needs to move to nothing. And then this fixing the broken link thing is only a problem if the head didn't move to nothing. Crazy. And then we got to knock the size down by 1. Oh, sorry, I forgot to switch back. Thank you, this nom. Okay, so here's pop front. Yeah, you could. So Magenta asks, could we use the size to detect these situations? So if like the size is 1, that's special, and if the size is 0, that's special. Yes, you can. I prefer to use the state of the pointers because I want to force myself to get the pointers right. But technically, if you are managing size and can rely on it being 1 when it should be 1 and 0 when it should be 0, then yes, you definitely can use the size to detect these weird situations. For teaching purposes, I want to kind of get you in the habit of thinking of where the pointers went, but you definitely can use the size if you prefer that. All right, so null out that guy if there is still a node. If there isn't still a node, then also tail needs to become null, and then I also need to knock down the size by 1. So Magenta asks, is there a situation where I would get the size back incorrectly? Only if you make a mistake. So yes, if you make a mistake, then that's a possibility. And it's easy to forget this counter. So either way, you have to either be very careful with the pointers or the size, or probably both anyway. So as long as you're careful with all of that stuff, then you should be able to rely on the size being correct. I almost forgot, for example, to knock it down to 0 here. Okay, so this is not a good test just yet, but we are kind of constantly running it. We're looking to see if we crash the, if we crash, then that would be bad. Okay, so must create, that's good. Let's create it. Let's size is 0, that's good. 10 to front, 5 to front, size is 2. Oops, I forgot to put the output for the T. And I forgot to call the function. All right, then we'll be done. All right, so I forgot to call the T. Else if command.at 0 equals the T, I am going to use my exception to deal with this. So try list pop front Catch. I should put an include for that here too. Okay, so try list.pop front. If I get a catch, I can simply say empty list here, which would be the only reason why this exception would happen is on an empty list. If I want to be cute about it, I can actually use the fact that I have that same empty list message in the exception that I threw itself, which is fun. If I get to line 46, then all was good. And I can say T, removed head. Which I forgot to do. Main. List size is 1. Let's do a couple of T's and call it a day. So that T should remove the last remaining one. And then I'll do the size. And then this T should try to remove a non-existent one, which should cause the program to grouse at me. I didn't need to recompile that, by the way. I just changed the inputs. There's the empty list being detected. So that's good news. At least it got that far without crashing. Yeah, let's do one more cleanup. Which is, this thing doesn't need to be here anymore. It just looks cruddy. Why, oh why, oh why don't I remember this? That's what we're looking for, is that kind of stuff. Okay. So, yeah, I put a break in the video so that the video can go back and be reviewed. It's a lot of project code in here, so I feel uncomfortable like just giving huge amounts of solution. So if it creates a problem for somebody and somebody wants to see the details of a specific function, please let me know by Canvas inbox or Piazza. But otherwise, hopefully the video is enough to get you going on those. And then in theory, you might be able to string from your singly linked list. You might be able to do clear from your singly linked list if you account for the tail pointer somewhere in all of that. You hopefully can deal with the push tail, push back, and pop back. You'll have to kind of think about which pointers in what direction as you work on it, but in theory, you might be able to get started on those. And if you were to manage all of that, printing is, we can take that almost directly from the singly linked list because we're just going to print from back to front. The size we've got pop the head. The return the contents of head and tail are relatively straightforward if you remember to use head for one side and tail for the other and do the exception thing. Get will maybe work on so these are the three there's four I'm going to work on next week, although one of them is not really working on it. I'll just use one of the others. So I've got 3 algorithms to do next week and a half. Inserting into the middle of the list. Removing a target from anywhere in the list. Removing all of a particular number if it should occur multiple times in the list. And then going out into the list and finding if I actually have a particular number. So anyway, those are the ones I'm going to work on the most next week in front of you. Okay, it's kind of fun. It's kind of hard. There's a lot of dang pointers. Hopefully you're getting practiced up on drawing pictures for yourself. Even what I've done for you today would get you a subset of the project. But anyway, hopefully that kind of launches you forward. So, yeah, thanks for sitting through this long. It is 12. I've been going for 2 hours minus the break. So if you could stick around this long, I hope it was worth it. And I appreciate it. Thank you, Tony. Have a good week. Oh, and Tony in chat did kind of follow me up. And earlier when we talked about can you use the size to detect an empty list, which is special here, or a one node list, which is special. And you can, unless you mismanage that size counter. So be careful of that. I'm going to use the pointers to get us in the habit of thinking that way. But either way, you have to take care because it's a complicated structure. All right. Thank you, Magenta. Have a good week. I'm going to stop here and get the videos processing. So see you next week. I'll work on some of these hard things. Hopefully you will have time to kind of do your best on the things that are similar to what I did today and to what you've been doing on the singly linked list. All right. See you Monday next week.